Hello, my name is Rob Reynolds, and I'm going to show you how to find the difference quotient. This is one of the first lessons that you'll need in your calculus class. The formula is given, and we're going to evaluate this for the function negative 17 divided by x squared. This becomes very important when I start talking about limits, but for today we're just going to find the difference quotient using this function. So I'm going to start out with something simple and look at f at 3. And if I were to evaluate 3 at this function, or find f at 3, everyone would just replace x with the 3, and then we get negative 27 over 3 squared. So the first thing I want to find is f of x plus h, and I do the similar process. It's negative 27. I'm going to replace x with x plus h, quantity squared. So first of all, I want you to realize this is the value of f of x plus h. So I'm going to replace f of x plus h with f of x plus h. So if this is the value of f of x plus h, I'm going to replace this yellow with yellow, and I get a new negative 27 over x plus h quantity squared minus the function. The function itself is f at x, so it's this green thing. So I'm going to replace the function with f at x with the function, which is a negative 17. Be careful, there's a double negative in here. And it's going to be all divided by h for the formula. So the yellow goes yellow. I've got f of x plus h in yellow minus the green function. That's f at x, all divided by h. So the rest of this is algebra. I got to find common denominators. Two negatives create a positive, so I'm going to rewrite this as negative 17 over x plus h quantity squared plus 17 over x squared. One thing that might be helpful, instead of having a compound fraction, I'll hit divide by h out here, and I'll, instead of dividing by a fraction, multiply the reciprocal in just a moment. But here, I need to find some common denominators. So I've got x plus h quantity squared and x squared. So I'm going to choose a common denominator of x plus h quantity squared, and I'll choose x squared, choosing every factor as many times as it appears in each denominator. It looks like the first one is lacking in x squared, so I'll have to multiply the denominator and the numerator by x squared. The second one looks like it's lacking the x plus h quantity squared, so I'll have to multiply the numerator and the denominator by x plus h quantity squared, bringing down a positive 17 x plus h quantity squared. And don't forget, I've got to divide by h. I'm going to rewrite that as times 1 over h. The next thing I'll try to do is simplify x plus h quantity squared. Be careful, the mistake is students will always try to tell me it's x squared plus h squared. You can't distribute that exponent over addition and subtraction, only multiplication and division. So I'm going to rewrite this. I'll leave the red 17x squared. I'll leave this 17 out there, and I'm going to properly FOIL this by squaring the first, twice the product, and square the last, all divided by the common denominator. And next I'm going to distribute the 17 to every term. And combining some terms, it looks like this will cancel, so I'm going to ignore the pink. It looks like I can factor out an h from the numerators after I've canceled out the pink. So I'm going to rewrite the numerator, factoring out an h, leaving with just 30. Well, actually, can we pull out a 17 as well? And that way, I won't be dealing with 34. I think I'll be down to another 7. No, how about a 2? X plus h. Ooh, that looks pretty good. times 1 over h, and it looks like I can cancel at least an h here. So I might be getting close to the final answer of, I think I got a 17 floating around. I got a 2x plus h, all divided by x squared x plus h quantity squared. And checking that with the author, that looks like pretty close. Now don't get this process mixed up with average velocity, which we're going to learn later. So this is your slope formula, which we'll learn later in this chapter. This is your average function. It's really just your slope, y minus y over x minus x, instantaneous velocity. But looking at how to evaluate this, it's a little bit different. This time it says start with the function, which is negative 17 over x squared. Subtract off f, evaluate it at a. Well, just like we did f at 3 before, let's evaluate f at a. By every time you see an x, plug in an a. So instead of negative 17 over x squared, I'll have negative 17 over a squared. And this is all divided by x minus a. So again, finding a common denominator, choosing every factor as many times as it appears. I have to choose x squared. I also have to choose an a squared. It looks like the first denominator is missing an a squared. So I'll bring over a negative 17a squared. The next denominator looks like it's missing an x squared. So I'll bring over, well, this is actually a positive then, 17x squared. And don't forget, it's all being divided by x minus a over 1. So I think I'm going to rewrite this as multiplying by the reciprocal. It looks like I can factor out, we'll pull out a 17 from the numerator. And instead of writing negative a squared, I'll put the x squared term first, just because it looks a little bit nicer. Instead of writing 5 minus 4, it's the same thing as negative 4 plus 5, but I just prefer 5 minus 4 over x squared a squared times 1 over x minus a. And I think I see something here. If I were to factor the difference of two squares here, this is x plus a and x minus a, I think one of those is going to cancel. So perhaps I'm getting close to the final solution. Check that with the author. Looks pretty good. I hope you found this helpful. If you have questions, email me.